Hello, RTD Math. Gina, your instructor today. We're going to continue with our theme of factors. As a reminder, a factor is a number that is going to be evenly divisible or divided evenly into another number. We're going to look at a special case of prime numbers today. And a prime number has only got two factors. Okay? The two factors for a prime number are 1 and itself. So we're going to start with a list from 2 to 20. We'll speak about the special case of 1 in just a second. And we're going to go through that list and we're going to figure out which ones are prime numbers. Then we can apply those principles to any number larger than 20 as well. So we'll start with the number 1. We know that the only two factors of 1 is 1 multiplied by itself. Okay? There's nothing else that can evenly divide into 1. But what we said was that a prime number is going to be divisible by 1 and itself. But 1 is itself, therefore 1 is not a prime number. It's one of those special cases where 1 actually is an anomaly. Okay? Ironically, 2 is also a special case. And 2 is a special case because 2 is the only even prime. Okay? Now we know that if we start on our nice list, I know that 1 multiplied by itself is going to equal to 2. That's perfect because that's the definition of a prime number. When I take 1 and I multiply it by 2, they are two separate factors, 1 and itself. And because there's no other number that evenly divides into 2, it makes 2 the only even prime. So there are your two special cases, 1 and 2. After that, there's no really many special cases going on. We'll continue with the number 3 and 4 and 5. Now, 3, we know that 1 multiplied by itself, definition of a prime, is also the two factors of 3. Nothing else is going to evenly divide into 3, so that's perfect. We know we've got 3. 4, it's got a couple more factors to it. We know 1 in itself, okay? 1 multiplied by 4 equals 4, but we also have 2 multiplied by 2, which is more factors than we require. And I know that this is actually going to be true for all other even numbers. Every other even number that is in existence is going to have 2 as its factor. But because a prime number is only allowed to have 1 in itself, it means that all other even numbers are now off of the list and not considered prime because it will have more than just those 2 factors. Okay? 5 has got 1 in itself and no other even number divides evenly into that. We can continue with 7, 9, and 11. Now 7, we have 1 and 7. 2, 3, 4, nothing else evenly divides into 7, so that's good. But 9 I want to focus on. We sometimes get tempted to say that if it's an odd number, it could potentially be prime or is prime, but that's not always the case, and we have to be careful with that. 9 definitely has 1 in itself as its two factors, 1 multiplied by 9. 2 doesn't go into 9 evenly because 9 is not even, but 3 multiplied by 3 is 9. So we know that because it has more than 1 in itself, it's actually got 3 times 3 as well, that 9 can't be a prime either. So we can't just go with the rule that all odd numbers are prime. That's not necessarily true. Now, lucky for us, 1 times 11 is just 11. There's no other number that divides evenly into 11. This is also true for 13. There's nothing that evenly divides into 13. But 15, on the other hand, we get 1 in itself, which is the definition of a prime, but we can also get 3 multiplied by 5. Notice I skipped the 2 here because it's not an even number, right? So I go up the next in the list, which is 3, and 3 times 5 is 15, so 15 is off the list. 17 is only 1 in itself, and 19 is only 1 in itself. So all of the prime numbers between 1 and 20 happen to be 2, 3, 5, 7, 11, 13, 17, and 19.